All right, so today we're going, going to study quadratic functions. We studied linear equations, and also we have done some exercise story problems using linear equations. But sometimes we have to deal with the quadratic equations. Okay, there are two types of quadratic equations. One is that's x squared is a positive number. Okay, so this a is going to be a positive number. Then you're trying to solve this equation. Okay, well, sometimes you cannot find the integers such square, even the square, for example, like 2, right? X squared equals 2. You cannot find the integer so that it's a square is going to be 2. So we have to introduce a notation. Okay, so we denote by square a the number, okay, the non-negative number whose square is going to be a. Okay, can we introduce a notation? There's only a unique number. If a is positive, it is positive. If a is negative, if a is 0, then it's 0. So maybe I should just consider positive. Okay, then make it much better. So a is a positive number, and square a is the unique number whose square is going to be a. Okay, so if but you also notice that the negative square a is going to be, right, square of square a, which is going to be a. So if we solve the equation x squared equals a, you're going to get the two solutions. Okay, and that two solutions plus minus denoted by plus minus square a. Okay, and in general, the solution will be irrational number, even a is a rational number. Okay, in general, okay, square a is an irrational number. Okay, such like square root of 2, square root of 3. Okay, now since 2 squared equals 4, so square of 4 is going to be 2. Okay, must be 2 because 2 squared is 4. So square of 4 square is going to be 2. So that is going to be 4. So square of 4 should be 2. Okay, that's about the square root. That is about the square root. Okay. Now what happens if a is negative? Okay, if a is negative, so if you look at this equation, okay, well, this one, yeah, has no real solution. Okay, means there's no real number satisfying. There's no real number satisfying this equation. Okay. Okay. There's no real number because the square of any real number is going to be non-negative. Okay. So you don't have a real number with that. So we have to introduce some imaginary number. Okay. So we denote by I the number, okay, such that, and that number it's not the real number, okay, such that I squared equals -1. Okay, so then x squared equals -1 has two solutions. Okay, x equals plus minus I. Okay. Once we introduce that special number I, then we can have a Then we can whatever we can, yeah. So square I formally can written like a square root of -1. Okay. Then then if we solve the equation, if we want to solve the equation, xi squared equals -8. Okay. So now we have an equation. Come on. X squared equals -8. Here's a is a positive number. Okay. So x is going to be plus minus square root of -8. Square root of -8 has no meaning here. So you can formally write as -1 times 8. Okay. Then that would be square root of -1 times square root of 8. And the negative square root of -1 is denoted by I, so it's plus square root of 8 times I. Okay. So you do have two solutions in general, but using yeah, so you have to use the I here. Okay. And then we have a so-called complex numbers. Complex numbers are written in the form a plus bi. Okay. So a, b are real numbers. Okay. And for complex number, it's like just like a real number. You can do the addition, multiplication, and the subtraction, whatever. Okay. So I'm not going to spend too much time on complex number, but yeah, the square is going to be any number, complex number. It's a square multiplication or two numbers still be in the same form. Okay, a plus bi. For example, 2 plus 3i times 1 minus I, and the product of two complex numbers. 2 times 1 is 2, 2 times -i is 2i, and plus 3i, and here -3 I square. Now I square should be replaced by what? By -1. So it's a 2 minus 2i plus 3i minus 3 times -1. And then 2 plus 3, it's a 5, and plus I. So the product of these two complex numbers, you get another complex number, okay, in the same form. Okay. So let's move on to the next, yeah, go back to go back to quadratic equations in general. Okay. So I'm going to solve this equation, x minus 5 squared equals 9. Okay. Now this equation can be written in many forms. Okay. This, if we expand it, this can be x squared minus 10x plus 25 equals 9. This could be yeah, written in the form like that, right? Okay, so they're either this form or that form. Okay. Well, we're trying to find the numbers satisfying this equation. So I think I'm going to view x minus 5 as one number. Okay, so this should be called plus minus square root of 9. Yeah, using that original one. Right. So that will be plus minus 3, because square root of 9 is going to be 3. Then x equals, move -5 to the both sides, 5 plus minus 3. Then you have two possible numbers. One is when you choose plus, you get positive. When you choose negative, you get 2. Okay. So there are two solutions. Typically, a quadratic equation has two solutions. One is 8 minus 5 squared is going to be 9, right? And also when they put 2 here, 2 minus 5 is in -3. So -3 is also equal to 9. So there are two solutions here. You check. Typically, a quadratic equation has two solutions. Okay, so let's take a look at the next one. X squared minus 2x minus 5 equals 0. Yeah, how do we solve the equation? Well, I'm going to use the following identity. Okay, x minus k squared equals x squared minus 2k plus k squared. Okay, 2kx. Or x plus k squared equals x squared plus 2kx plus k squared. Okay, so this is called the completeness square. Right, so step 1, x squared minus 2x equals 5. Now I have to add a number to the both sides so I can get the completeness square. So what I should add here? I think it's 2kx. 2kx should be 2, so k should be 1, so it's add 1 squared. Okay. Then the left-hand side is x minus 1 squared equals 6. Okay, x minus 1 equals plus minus square of 6. Okay, x is going to be, right, add 1 to the both sides. So you get 2 numbers. Now this time, those 2 numbers are real numbers, but they're not necessarily be rational number. Okay, now you can also verify, okay, both of them are the solutions, x1 equals. Yeah, you can check, okay, let's check, okay, check. Go back to the original equation. So x1 squared minus 2 times x1 plus minus 5. Okay, we can see. So it's 1 plus square root 6 squared minus 2, 1 plus square root 6 minus 5. And this should be equal to 0. It's not obvious, right, when you look at that. So we squared. So that is going to be 1 plus twice of square root 6. And the square of square root 6 is going to be 6. Okay, minus 2 square root 6 minus 5. Then you realize that, okay, this 2 canceled out. And the 1 plus 6 minus 2 is 5 minus 5, so it's going to be 0. So indeed, it's a solution. It's an irrational number. Okay, so this method is called the completeness square. Okay. Now, sometimes it's a plus 3x, right? Sometimes, this is not just double of some numbers. But remember, I have this formula, okay? Okay, I have this number, okay, 2k. All right, so step 1, I move 10 to the right-hand side. Okay. So I'm going to add, what number I'm going to add? Here 2k, here's a 3. So k should be what? K should be equal to 3 over 2. Okay. That's why k squared is 3 over 2 squared. Then this side, x plus 3 over 2 squared equals 10 plus 9 over 4. Okay, 9 over 4 is going to be, yeah, 49 over 4. Okay. And actually, 49 over 4 is going to be, 49 is 7 squared and 4 is 2 squared. So it's going to be 7 over 2 squared. All right, so this whole term square is going to be 7 over 2 squared. So this should be plus minus 7 over 2 squared. Okay, so it's a 7 over 2 plus minus. Okay, so you do get two solutions. Okay, so let me write these two solutions. Minus, yeah, move 3 over 2 to the left hand side. So we have to double check. Okay, I think when you choose plus, you get a 7 minus 3. It's a 4 over 2, which is 2. When you choose minus, negative 3, negative 7, negative 10 divided by 2, negative 5. So you have two solutions, 2 and the negative 5. Okay. So you're going to get two solutions actually. X1 equals 2, X2 equals negative 5. So these are two solutions. Yeah, this is a quadratic equation. How do you solve it? You know, it's a very basic formula. Well, yeah, let's do one more exercise. X squared plus x plus 1. So this equation, it's interesting. If you complete the square, right? So it's negative 1. And then you have to add a number. The number we're going to add is going to be, I think k is equal to 1/2 because this is supposed to 2k, right? 2k equals 1, k is 1/2. So it's 1/2 add 1/2 square. Okay. So the left hand side will be x plus k, x plus 1/2 square. So right hand side is negative 1 plus a quarter. So after you simplify, it will be negative 3 over 4. Okay, so this is going to be negative. So you can say no real solutions. Okay, no real solutions. Okay, now if you want to get a solution in more generalized area, you know, right, field. In the field of complex numbers, it has a solution. We usually say in mathematics, in the field of complex numbers, okay, it has two solutions. Two solutions. Okay, how to do that? So x plus 1/2 is going to be plus minus negative 3 over 4. So it has two solutions. It can be plus minus square of negative 1 times 3 over 4. Okay. So I can simply write square of 3 over 2 and I, because square of negative 1 is denoted by I. So there are two complex numbers. So x is going to be negative 1/2 plus or minus. Right? So you see, it's a combination of two numbers, the real part and the imaginary part, complex. Yeah. So you have two solutions, two complex numbers. Okay. Now, have you heard about quadratic equation? Quadratic formulas. It says that if you have a equation here, so here A, B, C are real numbers, right? And A is not going to be 0, otherwise it's not a quadratic equation. We can express two solutions in terms of A and B, C. That's surprised. Okay, now how to get this formula? You know, you may memorize this formula, but we can derive this formula here. Okay, we should know. Yeah, you can repeatedly do this by yourself. So how can I do that? Okay, so this equation is equivalent to, right? No problem. Right, that's what we have to do. Divide both sides by A. And that equation is going to be negative C over A. No problem, right? Now I'm going to complete the square. here's b over ax. So what I should add is actually b over 2ax squared. That's a k, because that's a 2k, right? That's a k squared. So 2k equals b over a, then k is going to be b over a. So let's simplify both sides. Okay, so the left hand side x plus b over 2a squared. The right hand side, I'm going to multiply this out to b squared 4a squared minus c over a. So they do not have a common denominator. So maybe I can put the common denominator, right? 4a squared minus 4a squared 4ac, right? All right, great. So that is going to be b squared minus 4ac divided by 4a squared. All right, so now you get some perfect form of the equation. Then you can solve that. X plus b over 2a is going to be plus minus b squared minus 4ac divided by 4a squared. Okay. Okay. So the square b squared minus 4ac is okay here. Now the denominator, a could be negative, could be positive. So because since you have plus minus in front of that, so you really don't need to worry about, just write a 2a here. Okay. Yeah. In general, square of a squared is going to be absolute of a. Okay. It cannot be negative. Okay. Absolute a could be plus minus a, depends, right? This could be a if a is positive. If a is negative, you have to remove the negative sign. And in order to remove negative sign, you have to put a negative sign in front of it. So that would be positive number. Okay, anyway, you will get either plus or minus, but the thing's already there is a plus minus here, so you don't need to worry about it. Okay, then finally you get negative b over 2 plus minus 2a. Okay, so that is a so-called quadratic formula. So if you have a quadratic formula, you can solve the problem quickly, easily. Right? You don't need you don't need a completeness square. You just plug the numbers into the formula. Okay, so let's take a look at this problem. Plus 3x minus 10 equals 0. Okay. Using the quadratic formula, right? Your a is going to be 1, b equals 3, c equals negative 10. So here the equation is going to be, okay, negative 2a, also 2a and then negative b, so plus, negative minus 3, plus minus b squared, 3 squared, minus 4ac. Okay, so negative 3 plus minus 9 plus 40. Okay, so that would be negative 3 plus minus square root of 49 divided by 2. So that's a 7, negative 3 plus minus 7. Okay, so if we choose a positive sign, you will get 7 plus 7, minus 3 plus 7 divided by 2, which is 2. If you choose a negative sign, that's going to be negative 5. Okay, so you get 2 roots, 2 and negative 5. All right, great. All right, so yeah, take a look at the next problem. So you are given the leading coefficient 2. All right, now can you solve this problem? find the solutions to this equation. Do you remember the quadratic formula? Right. Yeah, please go ahead. Work on this. All right, so we have two variables, right? 2x squared plus x minus 1. Okay, that's the equation, right? 2x squared plus x minus 1. So we compare the formula here. We already got formula ax squared plus bx plus c equals 0. Okay, right? And we know there's two solutions given by this quadratic formula, minus b plus b squared minus 4ac. Okay, so if you use a formula, then you don't need any tricks to get you don't need any tricks to get solutions. Okay, you just look at the numbers and plug into the formula. But I would do wish you to learn how to get this formula, right? And get this one, we use the so-called completeness square. All right, so let's write down this, right? Okay, a is 2, so it's 2a. Okay, b, negative b, right? So b has a negative, okay? B is 1, so negative 1. Plus minus b squared minus a is a 2 for a c. C is negative 1. Be careful about sign, okay? So c is negative 1. So now you simplify it. So b plus 8, and here's 4. Okay. All right, so you will get negative 1 plus minus square root of 9 divided by 4. And the square root of 9 is going to be 3. Right? Square root of 9 is going to be 3. Okay, so what do we get? When you choose a positive sign, you get one solution. I think negative 1 plus 3 is going to be 2. 2 divided by 4 is 1/2. If you have choose positive sign and negative sign, you will get, negative 4. That's a negative 1. So there are two solutions. And there are two solutions here. Okay. And 1/2 and the negative 1. So that's why how do you apply the quadratic formula to solve the problem? Okay. You don't need to repeatedly using the ideas we get. How do we get quadratic formula to solve the problem? You can use a formula. Okay. All right. Now, okay, you have time. So let's try to solve this problem. Okay, x squared minus x minus 30 equals 0. Okay. Please find all the solutions. Okay, you can use any method you want. Okay, so far we learned the two different methods, right? One is to completeness square. You get two solutions, or you use the quadratic formula. But actually, the quadratic formula also, we derive the quadratic formula using the completeness square method. Okay, so can you use a quadratic formula to solve the problem? Let me write down, if you haven't write down the quadratic formula, right? So you write down this. Can you plug that number for A and B and C, and then you simplify? Yeah. Okay. I only get answer from Ivan. Okay, anyone else? So let's see, what is A? A is 1, right? A is 1 related, B equals -1, C equals -30. So plug them into the formula. 2 times 1, -b plus minus b squared minus 4ac. Right? So then you have to simplify. -1 is +1, and that's a b squared plus 120 here, because -4 times -30 is 120. Okay. Now 1 squared is 1, so it's going to be 121 divided by 2. Now square root of 121. 121 is a perfect square, right? 121 is going to be 11 square. Okay, so that is why it's 1 plus 11 divided by 2. Now you're going to get two solutions. The first one, you choose a plus sign. So you will get 12 divided by 2, 6. Then you choose negative sign. Right? Then it'll be -10, right? Divided by 2. It's -5. So you got two solutions. -2. Okay? So 6 and the -5 is going to be solution. Okay, just plug the numbers into the quadratic formula and you simplify it. So you get two solutions. Okay, sometimes you do get a negative, do get a complex numbers. Okay, if inside the radical b squared minus 4ac is negative, then you get complex numbers. Okay. So now let's go back to the general theory. Okay, if x squared, ax squared bx plus c equals 0 has two real roots, we call roots, sometimes called solutions. Okay, x1, x2. Then you can express them in terms of x minus x1, x minus x2. But the leading coefficient here should be still a, because otherwise I don't get a squared. Okay, this is identity. Okay, this is identity. So in other words, if you have this equation x squared minus x minus 30, right? We get two roots. One is 6, other one is -5. So x will be -6, yeah, minus x1. And x minus x2 is minus -5. So we can written in this form. We verify, we double check, okay? So this will be x minus 6, x plus 5. Okay, and the last statement guarantee this is true. Okay, and we can see that we can multiply this out. Right, when we multiply this out directly, we can verify this identity. So x times x is x squared, x times 5 is 5x, -6 times x is -6x, -6 times 5 is -30. Okay, 5x minus 6x is going to be -1. So you get the same function back. All right. Okay, I wanted to solve this equation, then express it in the form of that. Okay, minus x1 minus x2. Okay, can you do that? How do you find the equations? How do you solve the equations? Right. Yeah, you can use the quadratic formula. You can also use the completeness square method, either way. But since we already learned the quadratic formula, so let's solve this quadratic formula by solve it by quadratic formula, right? So my A is 1. Let's mark it. B equals -1. C equals -12. Okay. So X is 2A. Negative B is a positive 1. Plus minus B squared minus 4AC. Okay. 48 plus 1 is going to be 49. Right? Then the square 49 is what? Square 49 is, it's perfect square, right? So it's 7. Okay, then you get two solutions. 1 plus 7 divided by 2 is going to be 4. 1 minus 7 divided by 2, -6. I think it's -3. Okay. So you will get x squared minus x minus 12 equal to x minus x1 and x minus -3. And that's what you get. Okay. So quadratic function, if you have two different roots, you can always expressed as a product to linear terms. That's called the factoring method. Yeah, from here to here, we call it factoring. Okay. But factoring a quadratic function can be done directly instead of going through the roots. Okay. So if once you get a fact, once you factor the quadratic function, so you also get the roots right away. All right. So I'm going to try this x squared minus x minus 12. Okay. So my goal is to express this in the form product to linear terms. Okay. Okay. So if you multiply this out, you get x squared minus mx minus nx minus mn. Right? We don't know what is mn. I forget the part we did. Okay. We start with this problem, x squared minus x minus 12. I want to express as a product of two linear terms. So I get x squared plus m plus nx plus mn. So I compare those two sides coefficients. M plus n should be -1. M times n should be -12. Okay. So by guessing, try what you can get. Right? Add them together should be the -1, the product should be -12. But 12, the cup 12 is going to be 1 times 12, 2 times 6, 3 times 4. So there are 3 different ways to get 12. All right, now the -12, then you have you don't know which number you can put a negative sign, right? Right. So for -12, then you have more choices. 12 equals -1 times 12, and 1 times -12. Okay, and then -2 times 6, or 2 times -6, or -3 times 4, or 3 times -4. So you have a total. We have a 2 times 6 choices. Okay, m may be one of the number, n is the other number. Now, what pair of numbers added together gives you -1? I think this one. I think this one. Right? This number, right? -3 no, +3 plus -4 is going to be -1. Right? So m times n is -12, and m should be 3, n should be -4. Then the product is -12, the sum is going to be -1. Okay, we got it. So x squared minus x minus 12 is x plus m, and x plus n, so -4. And that's what we got before, right? That's called factoring. But so our second problem is that, yeah, we're trying to factor x squared plus 2x minus 8. And now we learned how many ways to factor it. If you can find the roots, you can factor it. Or you can do like what I did. Yeah, so there are several ways to solve the problem now. Can you try this? We have to express in the form x minus 1, x minus x2. Okay. Yeah, if you use a negative sign, You can use a negative sign, right? So that means x squared minus x1x minus x2x plus x1, x2. Okay. Okay. So you compare both sides. Can you figure it out by guessing try to get x1, x2? Right? In some cases, you can do that because x1, x2 are integers. Okay, so x squared plus 2x minus 8. So you compare both sides. I think the sum of those two numbers should be equal to -2 because there's a negative sign in front of that. And the product of those two numbers is going to be -8. Yeah, compare those two, right? So you're looking for two numbers. There's actually the two roots. So the sum of them is going to be -2. The product of them is going to be -8. Then you look at the 8. 8 can be written as a product of two numbers. Okay, there are a couple ways to do, right? But then, yeah, x1 plus x2, there's just so many choices. Okay, so I'm going to do begin with the product. So 8, -8 is going to be -1 times 8 and 1 times -8, okay? And -2 times 4 and 2 times -4. That's it. And 4 times 2 is the same as 4 times 2 times 4. So you have a total, you have 4 choices. Now, which pair of the numbers added together is going to be -2? I think this pair. Okay, right? So x1 plus x2 is going to be -2. Okay. So x1 should be equal to 2, x2 should be equal to -4. Okay, so you get two roots. Yeah, so x squared plus 2x minus 8 is x minus 2, x minus -4. Okay. But I said that you can always find those two roots directly. Okay, I said that you just solve this equation, right? How do you solve it? You can use, I'm going to use the quadratic formula. That's fine. If you don't use the quadratic formula, or use the idea we used to get the quadratic formula, okay, is completeness square. Okay, then you, where's my file? Okay, yeah, okay. Then you add 1 square to both sides, right? So the left-hand side would be x plus 1 square. So right-hand side is 9. 9 is 3 square. Okay, so x plus 1 equals plus minus square root of 9, so plus minus 3. Okay, then x is going to be -1 plus minus 3. So you get two roots, okay? And the first one, when you choose a positive sign, the second, when you choose negative sign, so it's -4. Okay, once you get the two roots, and then you can express it, the product of two factors. So x squared plus 2x minus 8 is going to be x minus 1, x minus x2. So we get exactly the same answer, right? Great. So basically, given a quadratic function, you're trying to factor the quadratic function, or you're trying to find the real roots, okay, of this quadratic equation, corresponding quadratic equation. All right, so let's go back to the quadratic formula again. Let's understand this. Okay, we have two solutions, right? X is going to be negative b plus minus b squared minus 4ac. So as you can see that if b squared minus 4ac is negative, then it does not have a real number, no real solutions. Okay. And if b squared minus 4ac is going to be 0, then you only have one solution. Okay. But if b squared minus 4ac is negative, positive, then you have two solutions. Okay. Another solution would be negative sign. Okay. So sometimes you have to quickly check whether there's a constant, whether there's a solutions there. Okay, how many solutions you're going to get. Right. Okay, so if I have a equation like that, if x squared plus 3mx minus 4 has a unique solution, okay, what is the value of m? Okay, so look at this, right? And when it has a unique solution, only when b squared minus 4 is 0. So b squared, that's a b, that's c. So 3m squared minus 4ac. Okay, that should be equal to 0. Okay. Do you think it's possible? And then you get 4m squared plus 16 equals 0. No solution. So that means no matter what the value you can put there, this is a very special equation. It always have two solutions. Okay, it always have two solutions. Okay, and this is always a positive number. 3m squared plus 16 is always positive. Right? In fact, this is always positive. So positive means what? Positive means these have two solutions. Right. So it has two distinct solutions. Right? It has two distinct solutions. Right. Remember, a quadratic equation has two solutions, or one solution, or no solutions. Okay. Here's the question. If x squared plus 3x minus 11 equals 0. Okay. What is the average value of, what is the average value of two real roots? Okay, solution you can say. But we don't want to find the two real roots. We just want to find the average value. Okay. Now, how do this is the problem? Well, if you find the two real roots, you solve the problem, just add them together, divide by 2. Okay. But what I want to show is, I don't want to find the two real roots, right? I assume that they have two real roots. Okay, multiply this out, right? And so I get x squared minus x1 plus x2x and x1, x2, okay? You compare both sides. So what do you got? You get x1 plus x2 should be -3. And x1 times x2 should be -11. Okay, what do we want to find out? We want to find out the average value plus, right? But that's obvious here, average value, right? You already get the sum of this. So it's again -3 over 2, so it's -3 over 2. Okay, so you will get the average value immediately. Do you need to find the roots? The answer is no. Okay, if we want to find it, it will be complicated. Okay, I show you. Okay, so let's use a quadratic formula. So this is a B, that's a C, right? And A is going to be 1. So 2A negative B plus minus B squared minus 4AC. Right? So you will see that it's going to be 9. It's here's 44 divided by 2, right? 44 my plus 9 is going to be 53, I think. 53 is not a perfect square. So it's very strange number. So you get two roots. They are complicated. However, the average value would be simple. When you add them together, you get, you can solve that, right? So x1 plus x2, and I find out divide by 2, right? I find out square of 3 is a square, yeah. Square of 53 will be canceled out. Okay, canceled out. What is left is going to be -3 over 2 plus -3 over 2. Right, but then divide by 2. So again, -3 over 2. Okay, so that's the end of stuff. Okay, so what this example shows you, yes, you can, you're talking about, you're trying to find the average value of the roots. So it's clear you have to find the two roots, then add them together. Okay, but if you do that, you do get pretty complicated roots. Okay, like here, -3 square of 53 divided by 2. Another one is -3 minus square of 53 divided by 2. Then add them together, you get a -3 over 2. But I said that there's no need to do that. And then here's much short way, right? You assume this can be, this has two real roots, x1, x2, then this could be written as x minus x squared, x minus x2, then add them together, and you find out all you need is what is x1 plus x2. And you compare the both sides coefficients, it will be -3. Right, so that's it. Then you get the answer quickly without even finding the two roots. Okay, so let's stop here.